Welcome back students in the world of indicators. It's a colorful world and today I'll be putting more colors into it. I'll be dealing with two indicators, phenolphthalein and methyl orange. These two are just favorite in IDJ and medical examinations. I'll be taking up the cases, the illustration, and through illustration I'll be making you explain how the things work. Let us start with phenolphthalein. In the previous lecture, I have already dealt with it, and in the present lecture, I will be dealing it in a more different way. Let us take phenolphthalein as our first indicator in an experiment where we have taken analyte in a beaker and the analyte is NaOH. So the analyte NaOH is now titrated with a titrate HCl, a strong acid. Now what is going to happen? At t is equal to 0, starting point, we have NaOH in the beaker, and if we put a pH meter into it, the pH will be high. It has to be high because it's a strongly basic solution. So we start with this point. Look at this point, pH is high. Gradually we are adding the titrate HCl into it. The pH is slowly varying, it is slowly decreasing. And as I have already told you, it is a strong base, it will hold the keys in its hand and will not let the pH deviate much till it is present. It's a strong base. So you can simply see that there is a gradual decrease in the pH, decrease till we reach at this juncture. At this point, we see a sharp change in pH. The sharp change in pH is signal that NaOH is no more. At this point, the last drop of HCl goes into the beaker and the reaction is over. NaOH is it has completely reacted with the HCl. Now what is happening? If we have put phenolphthalein indicator into it from the beginning, the phenolphthalein will take its color pink because the solution is basic. As we reach at this point, the phenolphthalein is going to change its color from pink to colorless. I repeat, as this fluctuation, as this sharp change happens, it also simultaneously converts phenolphthalein from pink to colorless. So the moment pink color is rendered colorless, we come to know that the reaction is completed. Reaction has completed. Now, which reaction I am talking about? This reaction. The NaOH is reacting with HCl to render NaCl and water. So the moment this reaction is completed, a sharp change in pH is observed, and in that change itself, the phenolphthalein is changing from pink to colorless. The reaction is over. So there are now two terms which are generally coined in this perspective. First is equivalence point and the second is end point. Now let us try to understand in this simple situation what is equivalence point and what is end point. Mind you, when the reaction gets over, it is called as equivalence point. So as soon as this plunge is reached, we know that reaction is over, and at this point the equivalence point is reached. And the indicator phenolphthalein is also changing its color from pink to colorless. This particular incidence, this particular episode, the changing of color from pink to colorless of an indicator is called as end point. So end point is a point at which indicator changes its color. Equivalence point is a point at which the reaction gets over. So we have planned in such a way that as soon as the reaction completes, the indicator must change its color. And that is what the phenolphthalein is doing, and is doing absolutely good job. So, phenolphthalein is a good indicator, is a pertinent indicator for reaction between NaOH and HCl. Okay? Now, according to milli-equivalent concept, there were some milli-equivalents inside the beaker as analyte of NaOH. Let us suppose there were some 100 milli-equivalents of NaOH inside the beaker. As you are adding HCl, the NaOH is getting used up, and the moment you have added 100 milli-equivalents of HCl into the beaker, the reaction will be over, because the same milli-equivalents react. So the moment 100 milli-equivalent of HCl has been added into the beaker, the reaction is over, the equivalence point comes, and as per our planning, the phenolphthalein is changing its color, because the range of phenolphthalein to change its color comes within the plunge of the drop of pH of solution. It comes in this range. So as soon as this plunge is coming, the phenolphthalein is changing its color. It's called as end point, and end point is letting us know that equivalence point has arrived. So I hope this episode, this particular thing must be understood. Now let us come to the second type of indicator. Mind you, this is a different titration. In this titration, the analyte is different. Now we have not used the NaOH, instead Na2CO3. Na2CO3 is also a strong base. We have taken Na2CO3 inside a beaker as analyte. Again the titrant is HCl, a strong acid. Now there is a difference in the curve. Mind you, Na2CO3 is a diacidic base. Now how it is a diacidic base? Let us try to gain the strength, gain the insight by this graph. In this graph you must be looking at a starting point. This is the time when only Na2CO3 was there, no HCl was added. As soon as HCl is added, the pH starts declining. Then we are looking at a plunge, a sharp fluctuation. This is the first fluctuation we observe. Look, after this fluctuation, mind you, one reaction is over. It is called as first equivalence point, and I have written this reaction here at the bottom. Na2CO3 reacts with HCl to make NaHCO3 plus NaCl. This reaction, when gets over, this first abrupt change happens. This is called as first equivalence point. It indicates that the first reaction is over. Which is the first reaction? The conversion of Na2CO3 into NaHCO3. So the reaction of Na2CO3 with HCl is basically a combination of two reactions. Na2CO3 converting into NaHCO3 in the first step, that is the first equivalence point, and in the second stage, the NaHCO3 which is formed in the first reaction reacts with the HCl. Then only we can say the complete Na2CO3 has been exhausted. So after this particular equivalence point, we see again when we add HCl, a change in pH is happening, and at this point, again a sharp change is happening. Now again a sharp change is happening, so it itself indicates that some another reaction must have gone completed, and that reaction is this one. The NaHCO3 which is formed in the first reaction now is completely used up by the further addition of HCl. So we have got two reactions, so we must be having two equivalence points, and we are having two equivalence points. The first is at this point, this much of volume of HCl was required, and for the second, this extra was required. So this extra HCl was added to tackle with, to react with the NaHCO3 which is formed in the first reaction. I hope it must be understood. So the reaction of Na2CO3 is basically a two-stage process. In the first stage, Na2CO3 converts into NaHCO3. It is called as first equivalence point. In the second stage, the formed NaHCO3 is completely exhausting with the HCl that we have added further. So there are two reactions, two equivalence points. So there must be two sharp changes in the pH, and we have first change, second change. Mind you, the first change is meant for phenolphthalein to change its color. In simple words, when the first change is happening, when the first plunge fluctuation is happening, it encompasses the range in which phenolphthalein changes its color from pink to colorless. So if we had phenolphthalein into this beaker, then it would have converted from pink to colorless. But we have not used it. We have used alone the methyl orange. So we have used methyl orange alone. So what is happening? The first equivalence point is not indicated because methyl orange is not having the conducive environment to change its color. It is not having the conducive pH to change its color when the first equivalence point is coming. But it will change color. And the time is when the second equivalence point comes, when the second plunge comes, when the second sharp fluctuation comes. That fluctuation encompasses the range of methyl orange. In that particular range, methyl orange changes its color from yellow to red. It was waiting for its time to come. मेरा नंबर कब आएगा? And इसका नंबर आता है when the second equivalence point is arrived. During that sharp fluctuation, the pH of solution changes, which is conducive for the methyl orange to change its color. And the moment the color of the solution changes from yellow to red, we understand that the equivalence point has been reached, and that is what it is written. The moment this plunge comes, methyl orange changes from yellow to red, and that is the symptom that the second equivalence point has come. The second reaction is also over, and that is really has over, and this is the reaction. Sodium bicarbonate reacts with HCl to form NaCl and carbonic acid. So if I in nutshell try to explain the things, so the things are very simple. If you have NaOH in your beaker as an analyte, we need phenolphthalein indicator. As the NaOH is over, the phenolphthalein changes its color from pink to colorless. If you had Na2CO3 instead of NaOH inside the beaker as analyte, it will undergo two reactions stepwise. In the first reaction, Na2CO3 converts into sodium bicarbonate and NaCl. That particular reaction is called as, the completion of that particular reaction is called as first equivalence point. And if you had phenolphthalein into the beaker, inside the beaker, it would have changed from pink to colorless. So the first equivalence point is meant for phenolphthalein indicator to indicate that it has happened. If you are not having the phenolphthalein indicator, you won't be having any symptom or signal that the first reaction is over, obviously. But if you are having methyl orange from the very beginning, it is still waiting for its turn to come. It has not come till now, till the first equivalence point. So we are also not acknowledged that the first equivalence point has come. The solution will be yellow in color because methyl orange is yellow in the color. In the basic solution it is yellow, and in relatively acidic solution it is red. So it is in the first equivalence point also it is remaining yellow. We are not knowing. We have not come to know about the first equivalence point. So we are continuously adding HCl, but the moment second equivalence point, that is the formed NaHCO3, is finally consumed in the second reaction, the second plunge, the second change has happened, and this is the time for methyl orange. Methyl orange was waiting patiently for this time. And the moment this time comes, methyl orange changes from yellow to red. And we stop adding HCl and we say that, look, the Na2CO3 is completely exhausted now. It is completely exhausted, and all the HCl we have used has gone to neutralize sodium carbonate completely into 2 moles of NaCl and carbonic acid. 2 moles of NaCl, one from first equivalence point, second from the second equivalence point. So I hope these illustrations of NaOH and sodium carbonate must be understood.